Oke, boleh nampak kan?
Boleh sih.
Okay, so we will look into this last chapter. This is called Ensemble Classifier and Feature Selection. So this lecture will need you to understand the previous two lectures first. Actually, the last lecture, based on the previous lecture, we look into how do we use the supervised classifier to classify text document, kan? So before we can perform the classification, we need to perform. We need to split our data into training and testing data set. Then we model the data using the classifier that we have. So we call it modeling lah. Before we can perform the testing, we need to train our classifier first, kan? So when we have a new data set, maybe it's better for me to look into the. Okay. Oh, not this one. This one is not the one. So in the previous lecture, we study about supervised learning. So this is the diagram that we have. When we try to perform the classification, we first must perform the training phase. So in which we pass the label document. So this is your label document. And then we use the learning algorithm to model your data. So once we have a model, then we can use the testing data in order to measure the performance of your model. Okay, so when you have a new data, okay, this is your new data, and you feed into the model here, and then what you have here is the class label, kan? The predicted class label. This is the predicted one. Okay, so how many class we have here? Only one only. So one class label. So that means a new document given to you, you will produce one class label, predicted class label for this particular document. Okay. So the idea of having the ensemble classifier is that why not we have several model, okay, several model, then we will apply the classification using several classifier, and then we look at the result. Okay, so that is the whole idea of what is ensemble classifier. We make use of several classifier instead of using only one. Okay, but I think I forgot to record. Ada record kah? Oh, ada. Okay. So if we switch back to this lecture, so when we talk about ensemble classifier, we are applying more than one classifier. we make use of several classifiers. So the way we arrange the classifier is determined by the type of ensemble classifier that you want to use. Okay, why do we need to have a few classifiers? Because we want to get more higher accuracy, because instead of using one, we use several of them. So we combine the prediction of distinct classifier to generate a new predictive score. So that means if you have a few model, so this is model 1, model 2, model 3, model 4. So if you have a new data, you feed into this 4 classifier, and then the result of this will be combined to get the class label. Okay, so this is what we call the stacking. Okay, we will look into the boosting. The boosting, what it do, given a new document, it will feed into the new model. Okay, let's suppose feed to here, and whatever result you get, it will be fed into here, here, here. So in sequence. So the final one will be here. Okay. So we will look into these two, how they are used and how we set up this one. So first, let's take a look at the stacking. Okay. So let's suppose we have a training document here. So of course, your training document here will be changed to feature vector. So you have studied the TF-IDF. Okay. So individual record represent one feature vector. So, and over here we have a few classifiers. So support vector machine, naive Bayes, KNN, and many more. So these are the label that we get from our classifier. Okay, so when we arrange them in this order, so the true class here will be determined by the majority voting that we have from all the classifier. Okay, so we will do it for the first document and then the second document. So individual document will be classified by several classifier, and we will determine the class label based on the majority of your label here. Okay. So for each of the document, we will have to perform the same. So this is what we call meta classifier, in which we combine a few classifier, and we, for each document that we have, we try to predict them using this classifier, and we come up with the true class based on the majority of your voting here. Okay, majority of the class label produced for all your classifier here. Okay, so this is a good way for you to correct the incorrect result. For example, we know that support vector machine here will give you 1, but the rest of the classifier here will give you 0. So this one will compensate the classifier that will give you the wrong class label. For example, if you only use support vector machine, then you will get this label. So you have no other option to get the result. Okay? We rely 100% on this result because we are using one. But if we use all of this, then we can double check what is the best class label that should be assigned to the document. Okay? So by having this ensemble or the stacking based ensemble, we can improve the classification of our document. Okay. So any question? No?
No, sir.
So for the stacking method, learn function that combine prediction of individual classifier. That is the key. We combine prediction of individual classifier. So in this case, we are looking at the majority voting. How many number of ones? So the most number of class label here will be determined by the majority voting. Okay, so the final class label will be 1 because we have 2 1 here compared to only 1 0. Okay, and we do it for every document for the testing. Okay, so this is training phase and this is the testing phase. So based on the diagram that we have here, what we want to do is we want to have a document class pair. So we have the document and then we have the class label. So we use this information as a training set and then we model the individual classifier that we have. Okay. So once we have performed this, the individual modeling for this particular document, then we will get the result here. So instead of predicting class of DJ of the document, we predict the classifier that best predict the class of DJ. So which means that we look into this based on the majority voting, we will take the classifier that has 1 to be the classifier to be included as your meta classifier. So all the one that produce 1 will be taken into consideration. Okay? And we combine prediction of best classifier to produce better result. The advantage, error of a best classifier can be counterbalanced by hits of others. So that I mentioned previously. So only if one of them is 0, so this could be the error. So it can be compensated by having other classifier and we look into the class label. Okay, so whenever you see ensemble classifier, they are basically a meta classifier that combine several models prediction to get the single classifier, no, a single class label. Okay, next one is boosting. So if we refer to the previous one, boosting here, so given a new document here, so what actually we want to do is we want to feed this new document into this classifier model 1 and then whatever result we get here, we pass to the model number 2. But the weightage for each of the document in the pool here, we have a few documents here. Will be changed according to the condition whether they are classified correctly or not correctly. Okay. Okay, this is an illustration of the boosting based classifier. So in which you have the data here. So the data will be fed into this model. So of course you will have some of the sample to be classified as true or not true, positive true or false positive or true positive, meaning some of them are predicted to be the right class and some of them are corrected to be the wrong class. Okay, so still for this one we are using the same model. Okay, the same model here. Compared to this one, in the stacking, we are using different classifier. Okay, different classifier to combine. Compared to this, we are using the same model here, the same algorithm. Okay. So what will be focused will be the one that misclassified training document. So of course, when we try to predict, some of them we can predict correctly and some of them will not be predicted correctly. So we will focus more on the misclassified training document, which is wrongly predicted. And for each, at each interaction, each document in the training set is given an initial weightage. So weight of the incorrectly classified document are increased at each round. Okay, and also weight of the correctly classified document will be decreased at each round. That means we will focus more on the incorrect classified document. Okay, so after n round, we will have an output of trend classifier, which has a weightage sum. So di sini maybe the weightage for this classifier is 0.8, and then this is 0.3, and then this is 0.4. So this weightage will be computed based on how many number of record that we have here that correctly classified or not. Okay, so we will look into that one later on. So what we want to do is we want to find this weightage for each of the classifier based on the number of correctly classified text document that we have. Okay, so this is the most common boosting based classifier. This is called the ADA boost algorithm. Okay. So in your data, we have a training set function. So a training that function that will map the document and also the class label. Okay, and it says that let nt be the training set size and m be the number of iterations. So the m here is the number of model that you want to have. So in this example, your m is 3 because we have 3 model. So if you want to do 5, so your m will be 5. Okay. So the number of iteration here refer to number of models also. Okay. And we have this number of training sample that we have. So we use this one to calculate the initial weightage of each document. So how do we do that? So the weightage for each document that we have in your set will be computed as follows, where we get the weightage of individual document to be 1 over number of sample or number of record you have. Okay, so if you have 10 documents, so the weightage for each of the document will be 1 over 10. Okay, so for example, let's suppose we have this data set. So this is in your search space. We have 5 positive and we have 5 negative for the document that we have. So what we want to do is we want to have a classifier that will learn this. Then this is belong to the positive. This one will belong to the negative one. Okay, so the weightage will be 1 over 10 here because we have 10 document kan? So each one of them will have 0.1. Okay, 0.1. So that is how we initialize the weightage of each document by taking the number of the record and we get the weightage of each document by having this computation. Okay, so this M could be 2 or 3 or 4, it depends on you. So now, how do we compute the weightage for each of the model that we want to have here? So we have M number of models. So what we want to do is we want to compute the error that we have. So given a function that will divide the data set. So for this one, this is in an ideal condition in which I'm able to separate them correctly. But there is no classifier that can correctly divide the samples based on the space search that we have here. Okay. So based on this function, we will look into how many number of sample that is misclassified. So di sini we will look into the weightage that we have, and also this is the number of weightage for all member that we have. Okay, the summation of all the weightage from 1 to number of document that you have. Okay, so how do we compute this one? Okay, let's suppose we divide our search space into this one. So everything to your right will be negative. Everything to the left of you will be positive. So as you can see, this is correctly classified, but we have these 3 error. Okay. So the error will be we add up all this value, okay, and basically is 0.3 lah. So if you look at the formula here, so the weightage of all this misclassified, and then we divide by the number of weightage that we have here. So this is when we look at here. So this is your error lah. Okay. So we sum up all the error that we have for the misclassified one. Okay, so this is our error. Since this is partition using model 1, so we could compute the weightage for this by computing the next one, which is the alpha. Okay, so how do we compute the alpha here? So this is the computing the classifier weightage. So we have 0.5 times log 2 1 minus whatever error we have here in the previous one, and then divide by error. You could also use this one as the natural log or log base 2. In this example, we are using natural log. Okay, so we know the error is 0.3. Okay, so 1 minus the error divided by the error itself. So we use natural log and then times 0.5. So we get this. So this is basically the weightage of the classifier. Okay, so for you to compute the weightage of the classifier, we need to know the weightage of all the misclassified document that we have. Okay, so that is in the first phase. For us to go to the next phase, what we want to do is we want to increase the weightage for this, and we want to decrease the rest of them, because the rest of them we managed to classify correctly, kan? So we have to increase the weightage of this and decrease the weightage of this. So how do we perform that one? So based on this formula, for all correctly classified example, we want to update the weightage to be, we want to multiply with the exponential value of minus the error that we have. No, the minus the alpha k, which is the pemberat of the classifier. So this one will decrease the value of the weightage of the correctly classified example, and this one will increase. So how do we perform that? Okay, so this is the information that we get from here. Okay, now in the next stage is, okay, for all the correctly classified document, we will multiply with this. Okay, so the 0.42 coming from here, and we have minus there, so the value will be this, and we have 0.42 also, but there is no minus, so the value is 1.52. So this is the new adjusted weightage that we need to perform. Okay, meaning we have this one. If we go back to the formula here, we take the all one times with this. Okay, so we take the all one. The all one will be this one times this. So that's why we get 0.066, and this one is 0.152. Okay, this one coming from, we have the initial weightage times 1.52, then we get that. Okay, any question? So this is round one. Okay, round one, we compute the error, and then we compute the weightage of the classifier, and then we adjust the weightage of each sample that we have here. So there are 3 steps. Okay, So now we want to go to the next round. So because we want to treat this one as your new document with new adjusted weightage. Before that, we need to normalize this value. So how do we normalize? We add up all this value and you divide by that value. So for example like this, when we add up all this value, the value is this one, 0.918. Okay, so that means, let me erase this. We add up all this value, and we have this value. So to normalize each of this weightage, we divide them by 0.918. Similar to this, 0.918. Okay, and once you have done that, you will get a new weightage, which is this one. Okay, so we get this one. So this one is, we are getting from this one, 0.152 divided by 0.198. Then we get this one. Okay, so this is your new weightage, normalized weightage for the individual document that you have. So now we go to the next round. We're starting from the beginning again. Okay, so now let's suppose we have another model that divide this search space into two. So this is, everything on your right will be negative, and everything to your left will be positive. So based on this, we have three errors: 1, 2, and 3, because they are in the positive territory. Okay, so we add up the value here, and we get this. Okay, so we apply that one here and here, then we get the weightage of the classifier that we have, which is 0.65. In the previous one, we have 0.42. So this is model 1, this is model 2. Okay, so how do we adjust them? So we compute again the adjusted weightage by computing this one times with this one for all of this, and we get the new weightage of this, and the rest semua. Okay, so notice that this one is correctly classified tadi too, and this one is not. So the weightage has been increased. This one will be reduced, the weightage. Okay. Okay, before we proceed, these values must be normalized first. So what do? We add up all this value, and what we get, the value is this, and we divide all of this with 0.829, and we get new weightage here. This is previous, this is the new one. This is the normalized weightage after we divide all the previous weightage with these values. Okay, so now we take this one again. Okay, so we take this one again in round 3. Okay, and we have this one again. If you ask me where does this one come from, this is given lah. So this is given. It could be here. It could be here. So this is just to illustrate to you that we are using model number 3, and model number 3 divide the search space into this. So we have everything to your top from here will be positive. Everything here will be negative. So as you can see that we have 3 error, 1, 2, and 3. So we add up the value and we get this. So we do the same process, we get the weightage of the classifier. Okay. So if you want to go to the next round 4, so you need to perform the weight adjustment and the weight normalization. But if you decide to stop here, then at least you have 3 models with the weightage lah. So how do we apply this one? So we will form this formula. Okay. So this is the weightage of the first classifier, the first model. This is model number 2. This is model number 3. So this is your weightage. And this is how you split your data. So based on this, this is you split the data here. Okay. So how do we apply that one? Okay, let's suppose we want to predict X and Y. Okay, so X and Y. So for the X first, if you perform the X here, X here, X. So this is, we are in the negative zone. So that's why we put negative here. And this is in the positive zone. That's why we have positive. This is negative. So when we add up all this value, we have a single number here. Okay. So if the number is negative, then we assign the sample X here to be negative. If positive, then we assign the class label to be positive. Okay. So if we have a new item at this position, so we will apply again. So this is in the negative area. So we put minus, and then the next two will be in the positive. And we add up the value, we have positive value. So notice that, okay, this is positive. So majority is, yes, no, majority is positive. For this one, majority is negative, and then we get negative. So this is sample of soalan dalam final exam. Okay, so given this one is classifier 1, classifier 2, classifier 3. So you were asked to find what is the formula for this. The formula will be this one. So you need to determine this. So for you to form this formula, you need to compute the weightage of each of the model that you have here. Okay. So you need to produce this. So, and you will be asked again, what is the class label for this based on the function that you get. Okay. So the same example shown previously. So you need to determine which one A belong to, positive or negative. Okay. So this is your exercise, but I don't think you have to submit. But just for your Nila, just for your reference. Okay. So any question?
No, sir.
Boleh paham nggak?
Boleh, sir.
Sure.
Iya, tapi perlu tengok balik recordingnya.
Ya, tengok balik. Okay, so I will stop this one. Stop recording.